All right, so I'm gonna have to apologize for the background noise here because I forgot to hit record as I was doing it with the class. So we are going to model light-independent reactions. And so here's like my little placemat to give you some orientation. We are inside the chloroplast and specifically in the thylakoid membrane. So these green circles with, the lines shown across is the double membrane of a thylakoid, okay? Slide this over just a little bit more. Okay, so this is inside the thylakoid. This is the stroma of the chloroplast. This is supposed to represent a photosystem. This is supposed to be my ETC. Over here is my ATP synthase. And then these are the players or the pieces. So I'm going to set it up. So I'm going to create a water molecule. So to do that, I'm going to find my electrons. I'm going to hide them behind the oxygen. And I got some hydrogens. Here's my water molecule, H2O. Okay, I'm going to stick my ADP plus P at the end here of ATP synthase. And I'm going to take my NADP plus, which is my electron carrier, and set that in the stroma. Now this isn't an exact representation because there's 4 parts to this. Photosystem 2, ETC, and there's actually another photosystem that I have not included. And maybe I should in the future, but right now I have not. So this is how it works. It starts off with water in the stroma. So water enters the plant in the stroma. And when sunlight comes and hits it, water splits. And we generate oxygen gas, okay? And that's going to leave the plant, and that's the oxygen that we breathe. And we also have these electrons and these hydrogens that have also been separated. So the hydrogens split, and our electrons actually go to photosystem 2, where they get energized by more light, right? So they get super energized and they pass through a series of proteins called the ETC. And as it's passing through, hydrogen gets pumped across to the inside. Then I'm going to move them over here because they're going to be used to make ATP later on. Now, in my real diagram, these electrons would go through photosystem 1 and get re-energized, but I don't have that. So we'll just say after they're done with the ETC, these electrons get picked up by an electron carrier, NADP+. So I'm just going to hide them behind there. And then these hydrogens, we have this concentration gradient that's built up. They're going to travel down the ATP synthase, and when they travel, they're going to turn ADP. No, I'm recording. I have it on my screen here. I'm not recording with my iPad. I'm recording with my MacBook. Nope, you're all good. It's good. So as the hydrogen travel down the ATP synthase, ADP becomes P. And these hydrogen ions also get picked up by NADP plus to become NADPH. And then what's the fate of these 2 molecules? Well, they're going to move on to the light-independent reactions, which is another lecture, another day, and leave. So that's kind of how you kind of have to quiz out. So you'll do this verbally, you'll walk me through everything, okay? And then I might quiz you saying, show me the stroma, show me the ETC, show me the ATP synthase, and if you don't tell me the fate of these molecules, I might ask, hey, what happens to them? So every quiz is different. It's not the same, but I'm going to quiz you enough so I know that you know what happens in light-dependent reactions. Okay.